Good day mga anak. So for today's discussion, we will discuss interval estimate of the population mean. Our discussion by giving the objectives of our lesson. Again, our lesson is interval estimate of population mean. The first objective, at the end of this discussion, you have to define confidence level. Second objective, we have to define confidence interval. The third one, we have to apply normal curve concepts in computing the interval estimate. And lastly, at the end of this discussion, you have to compute the confidence interval estimate. Before we proceed with the main lesson, let us recall the point estimate. We discussed last time the point estimate, which is the numerical value which gives an estimate of parameter. The best point estimator is the sample mean. The average comes from the population or from the sample. It is called point estimate. But the best point estimator, always remember, is the sample mean. Next, let us have the interval estimate. Let us also recall what is an interval estimate. So again, it can be calculated using two numbers or values which may or may not contain the value of the parameter being estimated. Interval estimation gives us a range of values. So last time, if you still remember, we have the lower bound and the upper bound. So that is the minimum value and the maximum value wherein the true population mean belongs. Now let us proceed with another term. We have the confidence interval. So a confidence interval, that is the interval defined within the true population where members of the sample are expected to be found. Next, we also have the confidence level. Confidence level is in a form of percent. Okay, so the confidence levels of 90%, 95%, and 99% are usually chosen. Proceed with the margin of error. It is also known as maximum error. The formula for the margin of error, that is equal to the z-value sub alpha over 2 multiplied by the population standard deviation divided by the square root of the sample size. Anak, remember the formula for the margin of error or the maximum error, ang ginagamit nating symbol for the margin of error is small letter E. Okay, we have the product of the z-value sub alpha over 2 and the standard deviation divided by the square root of the sample size. So again, we all know that the small letter n will be our sample size. The small sigma is the population standard deviation. And paano naman natin makukuha yung z value sub alpha over 2? That is the z value na makukuha natin sa ating z table wherein hahanapin natin ano ba yung z-score na nagko-correspond doon sa area na ibibigay sa atin nung 1 minus alpha over 2. So, it will depends on the confidence level na ibibigay sa atin sa given situation. So, later on sa ating susunod na example, mas madidiscuss natin how to compute for the z sub alpha over 2. Now, let us have an example. The mean score of a random sample of 64 grade 11 students who took the third quarterly assessment is calculated to be 27. The population variance is known to be 0.09. Let us solve for the margin of error. So again, we will use the formula for the margin of error. That is E is equal to the product of the z value sub alpha over 2 and standard deviation over the square root of the sample size. So from the given situation, we have the variance as 0.09 a sample size of 64. We compute the margin of error, kailangan meron tayong level of confidence. So in this given situation, we have to find the 95% confidence interval for the mean of the entire grade 11 students. So ibig sabihin, in this situation, ang binigay sa atin na level of confidence is 95%. So first, kunin muna natin yung z-value at 1 minus alpha over 2. So we now have z value sub alpha over 2 that is equal to 1 minus alpha all over 2. The given level of confidence is 95%. So therefore, the alpha is 0.05. So we have 1 minus 0.05 divided by 2. And 1 minus 0.05 divided by 2 is equal to 0.475. So now, what is the z-value that corresponds to this area? So ito yung area na makikita natin sa ating z-table. So using our z-table, so as you can see mga anak, dito sa ating z-table, dito natin hahanapin yung ating nakuha na 1 minus alpha all over 2. So, ano yung nakuha nating area? That is 0.475. So, hanapin natin siya dito sa z-table. So, as you can see, anak, ito yung ating 0.4750. So, tignan natin, ano ba yung kanyang corresponding z-value or corresponding z-score? So, tignan natin dito sa kanyang left side. Ito po yung ating first 2 digits. And then, sa top area, ito po yung ating third digit dun sa ating z-score. So, therefore, the z-value is 1.96. Siya po yung ating z-value at 1 minus 0.05 divided by 2. So again, mga anak, when the level of confidence is 95% and you have to find the z-value wherein your level of confidence is 95%, ang kanyang corresponding z-value ay 1.96. Tayo ngayon dito sa ating situation. Ang nakuha natin na z-value ay 1.96. So, siya ang ating z-value sub alpha over 2. So, ready na po yung ating mga given. We have the z-value, the sample size, but we have here the variance. Ang kailangan natin sa formula ng margin of error ay population standard deviation. So, anong gagawin natin? If you still remember, the standard deviation or the population standard deviation is the square root of the population variance. So, therefore, if your variance is 0.09, our population standard deviation is the square root of 0.09, which is equal to 0.3. We may now compute for the margin of error. So again, let us collect the information. We have the z-value sub alpha over 2 is 1.96, where the confidence level is 95%. The population standard deviation is 0.3. And the number of sample size is equals to 64. So now let us compute for the margin of error. We have E is equal to 1.96 multiplied by 0.3 all over the square root of 64. So we have 0.0735. So we have a margin of error of 0.0735 with a confidence level of 95%. Proceed with the interval estimate. Pag sinabi nating interval estimate, the member of the sample would fall within this interval of the true population. So the formula for the interval estimate, we have the sample mean minus the z-value at 1 minus alpha over 2, or the z-value sub alpha over 2 multiplied by the population standard deviation divided by the square root of the sample size. That is our lower bound of the interval. While the upper bound of the interval estimate is the sum of the sample mean and the z-value sub alpha over 2 multiplied by the population standard deviation divided by the square root of the sample size. So again, in an interval estimate, it is consist of the lower bound and the upper bound, wherein the member of the sample would fall within this interval. So again, interval estimates, it also quantifies the probability in which a member of sample would fall within a known interval of the true population. Now let us have an example. So from the previous example, we find the margin of error where the given level of confidence is 95%. So now let us have the interval estimate of that situation. So let us find the 95% confidence interval for the mean of the entire grade 11 student. And for us to determine the confidence interval for the mean, we have the lower bound and the upper bound, or the formula for the confidence interval for the mean. We have the sample mean minus the z-value sub alpha over 2 multiplied by the population standard deviation divided by the square root of the sample size. While for the upper bound, we have the sample mean plus the z-value sub alpha over 2 multiplied by the standard deviation divided by the square root of the sample mean. So, kanina, sa example natin, ang ating sample mean ay 27, while the margin of error is 0.0735. So, first, let us have the lower bound. So, we have the sample mean, which is 27, minus the margin of error, that is 0.0735. And for the upper bound, we have 27 plus 0.0735. Therefore, the lower bound is 26.9265 and the upper bound is 27.0735. This means that the member of the sample will fall within these intervals. Mga anak, our formula for the interval estimate of population mean when the population standard deviation is known and the sample size is greater than or equal to 30. For us to simplify the formula for the interval estimate of the population mean when the population standard deviation is known and the sample size is greater than or equal to 30, we have the sample mean minus the margin of error, that is less than to the population mean, and it is also less than to the sum of the sample mean and the margin of error. So if you are going to write that in an interval notation, we have the lower bound as the difference of the sample mean and the margin of error, and for the upper bound, we have the sum of the sample mean and the margin of error. Let us have another example. A researcher wants to estimate the number of hours that 5-year-old children spend watching television. A sample of 50 5-year-old children was observed to have a mean viewing time of 3 hours. The population is normally distributed with a population of a standard deviation 0.5 hours. So let us find the 90% confidence interval of the population mean. So let us have the first step. The first step, we have to determine the point of estimation or the point estimate. Mga anak, if we are going to determine the point estimate, we are looking for the average. We are looking for the sample mean. And the sample mean in this situation is the viewing time, which is 3 hours. Point estimate is 3 hours. Next step, we have to state the level of confidence. In the given situation, the level of confidence is 90%. For the third step, we have to collect and present sample evidences. Situation, we have a sample size of 50 and a standard deviation of 0.5 hours. So the sample size is 50 and the standard deviation is 0.5 hours. In this situation, we want to find or we want to determine the estimate number of hours that a 5-year-old children spend watching television. And present the other evidences. Let us proceed with the step 4, which is we have to determine the z-value at 1 minus alpha over 2. So again, in determining the z-value, we have z sub alpha over 2, that is equal to 1 minus alpha divided by 2. Since the given level of confidence is 90%, the alpha is 0.10. So we have 1 minus 0.10 divided by 2. We have 0.90 divided by 2. We have 0.45. So therefore, we have to find the z-value at 0.45 as the area. So we will use the z-table. Find the area, which is 0.4500. And let us also determine its corresponding z-value or z-score. So we have 0.4500, that is the z-value at 90% level of confidence. So since 0.450 is between 0.4495 and 0.4505, we will get the two z-scores, which is 1.64 and 1.65. Since yung nakuha nating area is 0.450 and the corresponding z-score is between 1.64 and 1.65, we have to get the average of 1.64 and 1.65. 0.64 plus 1.65 divided by 2, we will have 1.645. So we may say the z-value at the area of 0.45 is 1.645. The z-value sub alpha over 2 is equal to 1.645. Next step, we have to find the maximum error or the margin of error. So, pwede na nating i-compute dahil nakuha na natin yung z-value at yung iba pang evidences or yung given sa ating situation. So, we have the margin of error is equal to the z-value sub alpha over 2 or the z-value at 1 minus alpha over 2 multiplied by the population standard deviation divided by the square root of the sample size. So again, the computed or the corresponding z-value at 1 minus alpha over 2 with the confidence level of 90% is 1.645 multiplied by the population standard deviation, which is 0.5 hours, all over the square root of the sample size, which is 50. So we have square root of 50. Therefore, the margin of error or the maximum error is equal to 0.1163. after finding the margin of error or the maximum error, we may now proceed with determining the confidence interval estimate. So for the step 6, we have to find the lower bound and the upper bound of the intervals, or we may say we can now determine the intervals or the confidence interval estimate by getting the sample mean. So again, our sample mean is, which is 3. So for the lower bound, we have the sample mean minus the margin of error. And for the upper bound, we have the sample mean plus the margin of error. So therefore, we have 3 minus 0.1163 as our lower bound. And for our upper bound, we have 3 plus 0.1163. So the intervals are 2.8837, while the upper bound is 3.1163. So we have now our confidence interval estimate. So for our last step, we have to describe the result. So again, we have to interpret the results. So thus, we can say that with a 90% confidence that the interval between 2.8837 and 3.1163 contain the population mean based on 55-year-old children's TV viewing time. So for your offline activity about confidence interval estimate, ang given situation, mga anak, is the GPAs of entering mathematics major. So the situation is a random selection of 40 entering mathematics majors has the following GPAs. Assume that the standard deviation is 0.46. You have to estimate the true mean GPA with a 99% confidence level.